Io is known as one of Jupiter's moons, with a radius only about 5% larger than Earth's moon. And yet, stunning new discoveries from NASA's Juno spacecraft have left scientists astounded, because this seemingly small, distant satellite may just be one of the most mysterious worlds in the entire solar system. What they found was extraordinary. Io's surface is home to hundreds of constantly erupting volcanoes, with plumes reaching heights of up to 500 kilometers. Massive lava lakes boil endlessly, while isolated peaks, some as tall as 7 kilometers, rise from frigid plains, and massive collapses reshape the terrain in mere moments. This is a world in motion, raw and unforgiving. Even Io's colors are surreal. Brilliant yellows, deep reds, greens, and stark whites paint the landscape. But these hues don't come from sunlight. Instead, they're the product of violent chemical reactions between sulfur compounds, sodium, and toxic gases venting from the depths below. So what could afford such a chaotic moon? Perhaps the very world once thought too volatile to exist holds the key to the strangest stories still untold. Data from the Voyager missions, the Galileo orbiter, and most recently NASA's Juno spacecraft have precisely defined Io's position. It is the third largest of Jupiter's 4 Galilean moons. Orbiting at just 422,000 kilometers from the planet, closer than Europa, Ganymede, or Callisto, its radius measures 1,821 kilometers. But what sets Io apart is its density, averaging around 3.53 grams per cubic centimeter. It ranks among the highest of any major moon, significantly denser than its icy neighbors. Spectral analysis and gravity-based modeling confirm that Io harbors a core composed primarily of iron and sulfur, encased within a silicate mantle strikingly similar to the ancient rocky planets of the inner solar system. This dense core not only accounts for Io's stronger gravity compared to icy moons, but also lays the groundwork for its intense geological activity. One remarkable and unmistakable trait, Io's surface shows virtually no large impact craters, a rarity among moons and planets alike. According to NASA, this indicates that Io's surface is continuously renewed by eruptions of molten lava, erasing the scars of meteorite impacts. This surface is geologically young, with an average age measured in mere millions of years. A blink of an eye compared to the static, ancient crusts of other planetary bodies. Io races around Jupiter at nearly 17 kilometers per second, completing an orbit in just 1.77 Earth days. Observations through modern telescopes confirm that Io is tidally locked always, showing the same face to Jupiter, just as our moon does to Earth. This synchronization generates unique gravitational cycles, unlocking clues to Io's internal structure and the restless energy that drives its surface. Its extraordinary position, compact composition, and perpetually rejuvenated crust make Io a true anomaly. unlike any of the quiet, icy moons farther out. These defining features are the very foundation for the strange and powerful phenomena Io displays today, and they form an irresistible invitation to anyone seeking the outer limits of planetary science. Because of its extraordinary position, Io isn't just another satellite orbiting a parent planet. It's the focal point of one of the most complex dynamical systems in the solar system. Io completes a full orbit around Jupiter in just 1.77 Earth days, a blistering pace compared to other major moons. But the true strangeness doesn't lie in the timing of its orbit, it lies in the shape. Io doesn't travel in a perfect circle. Instead, its path is slightly elliptical and oval, that's constantly stretched and reshaped by gravitational forces far beyond the expected. Observational data from Voyager and Galileo reveal that Io is trapped in a powerful three-body orbital resonance with Europa and Ganymede. Specifically, for every one orbit Ganymede completes, Europa orbits twice, and Io races ahead with 4 full revolutions around Jupiter. This gravitational resonance creates a constant, rhythmic tugging and squeezing and releasing Io in a fixed beat, like a cosmic instrument stretched to its limits and then let go, again and again. As a result, at every point in its orbit, Io feels not only the immense pull of Jupiter, but also the disruptive gravitational influence of its sibling moons. The total gravitational force acting on Io is never stable. It fluctuates endlessly. NASA compares this to twisting and squeezing a soccer ball millions of times. The pressure and friction this generates within Io is enormous. This repetitive flexing produces a unique internal heat source, one powerful enough to melt solid rock and form massive underground magma chambers just beneath Io's fragile crust. The orbital resonance also keeps Io's orbit from ever becoming perfectly circular. Its shape remains slightly flattened. Preventing tidal effects from fading. Instead, they persist at full strength. Sustaining the satellite's internal energy supply without pause. This continuous heat flow fuels Io's fierce geological activity and serves as the foundation for dynamic mysteries that continue to challenge modern planetary science. In this way, the space around Io becomes a living laboratory where the invisible forces of gravity act not as theory, but as reality, playing out across planetary scales and triggering phenomena that humanity has yet to fully decode. Building on the previous mystery of orbital motion, a natural question arises. What does all that colossal energy, some relentless tidal flexing, do to Io itself? The answer, revealed through missions like Galileo and Juno, is nothing short of extraordinary. Unlike most planets and moons, where internal heat comes from radioactive decay or the leftover heat of formation, Io's energy is born almost entirely from tidal forces. The mechanism is deceptively simple, yet profoundly complex. As Io swings along its eccentric orbit, both crust and core are constantly stretched and compressed. This motion creates intense internal friction, not at a single point, but across the entire moon's structure. The result? An astonishing release of heat, strong enough to melt solid rock into magma, simmering just below the surface. NASA's geophysical models estimate that the total energy released by tidal friction within Io can reach up to 100 million megawatts, hundreds of times greater than the combined energy of all Earth's geological activity. This explains the underground magma chambers detected through seismic and gravitational data, each chamber acts as an autonomous geothermal engine. Ready to erupt the moment pressure exceeds its limits. Io's surface becomes a battlefield of constant change. Crust shattered and reborn over and over again. Reshaped by unstoppable thermal convection, what truly sets Io apart is the persistence of this internal heating. Unlike other worlds where heat fades with time, Io remains perpetually active. This ongoing energy cycle is why Io is the only known body in the solar system with continuous volcanic activity for millions of years. A record unmatched by any other planet or moon. But this isn't just a physical anomaly. It's an open window into planetary evolution. Io's volcanic fury provides a rare opportunity to test real-world models of internal heating, orbital mechanics, and geodynamics. By studying it, scientists inch closer to understanding how energy shapes the destinies of distant worlds. And perhaps how life itself might one day rise from such chaos. Is this very tidal effect unique and relentless that has transformed Io into a world where geology doesn't just exist. It erupts in its most violent form. Nowhere else in the solar system is internal energy expressed more powerfully than through Io's sprawling, diverse volcanic system. Observations from Voyager, Galileo, and most recently Juno have confirmed that Io hosts over 400 active volcanoes, more than any other known planet or moon. But the eruptions here are not bound by the rules we know on Earth. The Io's volcanic outbursts are extreme by every measure. Recorded images reveal lava and gas columns shooting 300 to over 500 kilometers into the sky, high enough to escape Io's own gravity and drift into Jupiter's magnetic environment. The temperatures at the most intense eruption sites can exceed 1,300 degrees Celsius, far surpassing the heat of almost all lava flows on modern Earth. Instead of the classic cone shapes seen on Earth, Io's surface is dominated by enormous lava lakes, such as Loki Patera, which spans an area 10 times the size of New York City. Constantly resurfacing itself with each eruptive cycle. Then there are fractures like Imerani, stretching hundreds of kilometers and erupting continuously for years. Creating vast plains of molten terrain. The Pele Ring and Tavashtar Patere have also been identified as epicenters of violent eruptions. Ejecting tens of millions of tons of material into space with each outburst. Io bears almost no ancient impact craters. because any mark of the past is rapidly buried under new lava. According to NASA, the average surface age of Io is estimated to be only about 1 million years. A blink of an eye compared to the geological ages of other celestial bodies. Its surface is in constant flux. Continually destroyed and reborn by volcanic fury. Io stands as a living geological laboratory. An environment where volcanic processes and surface evolution unfold at scales and speeds that until now, scientists could only model in theory. And through the eyes of interplanetary missions, we are not just watching, it's as if we are stepping inside a cosmic engine. Decoding cycles of energy and motion that no other world has ever dared to show us. The geological violence of Io doesn't just explode upward in towering volcanic plumes. It stains the moon's very skin with color and chemical signature. These vivid imprints have become Io's unmistakable identity. Captured in spectral data and color images from Galileo, Juno, and Earth-based telescopes. Every terrain, every glow tells a unique chemical story. Is the only known celestial body in the solar system whose surface is almost entirely blanketed in sulfur and sulfur dioxide. an outcome of the hundreds of volcanic eruptions that scar its face each year. Brilliant yellows trace where crystallized sulfur settles in thin layers. Deep reds and oranges mark regions where short-chain sulfur compounds have been chemically altered by heat or intense radiation from Jupiter's magnetosphere. Most striking of all, green patches caused by sulfur monoxide signal chemical reactions so exotic they occur only under Io's extreme heat and energy conditions. Each time Io slips into Jupiter's shadow. Its wispy atmosphere of sulfur dioxide condenses into a pure white frost. Cloaking the surface in a temporary chemical snow. When sunlight returns, that frost sublimates instantly, vanishing into gas. Creating a never-before-seen cycle of atmospheric freezing and vaporizing. NASA and international research teams confirm that this dynamic cycle plays a critical role in material transport. Constantly reshaping Io's volatile landscape. This palette of alien colors is not just aesthetic, it's evidence. It tells of brutal physical and chemical processes unfolding non-stop. The shifts in chemistry are both consequence and cause. They sculpt and evolve the terrain. Driving change across the surface in ways that defy every Earth-based standard. Each volcanic eruption becomes a brushstroke in an ever-shifting masterpiece. A canvas of raw chemistry that modern science is still struggling to decode. From its breathing atmosphere to its electric bond with Jupiter, attention now turns to Io's extraordinary landscape. An alien world sculpted by immense internal pressures and unconventional tectonic forces. Observations from spacecraft and high-resolution imagery from the Juno mission reveal a surface unlike any other. Towering mountains, deep valleys, fractured basins, and lava plains that evolve at a pace far beyond the geologic norms of other celestial bodies. Among the most striking geological features are Io's solitary mountain ranges. Massive, isolated peaks born not from Earth-like tectonic plates or volcanic chains, but from explosive crustal stress. The Busal Montes Range, with South Busal Mons rising over 18 kilometers high, holds the record as the tallest known peak on any moon in the solar system. These mountains stand alone, jagged and detached, rising starkly from lava fields and massive collapse zones. Their presence indicates that Io's internal energy isn't channeled through plate movement. But instead bursts forth in bursts of uplift and collapse, driven by deep episodic geodynamic surges. Recent studies using digital terrain models and Juno spectral data have uncovered peaks like Steeple Mountain, rugged giants standing 5 to 7 kilometers tall. Emerging from chaotic surroundings. These features likely formed when vast magma chambers beneath Io's thin crust began to empty. Causing the ground above to pressurize, bulge upward, and then collapse dramatically. This process carves out sharp, unforgettable scars. Evidence of a tectonic system that flips our Earth-based rules upside down. Beyond its peaks, Io hosts sulfur-rich plains like Medea Reggio. Ever-changing lava lakes and transient basins with towering cliffs that rise and vanish in a geological blink. Every terrain feature on Io exists in a state of dynamic balance, where the surface is constantly destroyed and reborn through thermal cycles. Crushing pressures and the interplay of tectonics, eruptions, and sudden subsidence. Io's landscape and tectonic behavior not only offer clues into how small moons can remain geologically alive, but also lay the groundwork for revolutionary theories about planetary evolution beyond our solar system. Could there be other such volatile, unpredictable worlds out there? Moons and planets where chaos is the norm and dynamism, not stability, shapes their fate? Beyond its violent terrain and volatile surface, Io's deepest mystery lies not in what erupts from its volcanoes, but in what simmers beneath. For decades, scientists have debated what powers this moon's otherworldly fury. Early theories proposed a global magma ocean beneath its restless crust. A seething, molten sea that fuels Io's unmatched volcanic activity. But recent gravity measurements from NASA's Juno mission have painted a picture far more complex. And far more surprising. Juno's gravity data and seismic inferences suggest there is no single, continuous ocean of magma beneath Io. Instead, scattered across its interior are isolated magma chambers. These local reservoirs are formed in zones most affected by Jupiter's intense tidal forces. In these hotspots, the gravitational stress is enough to melt solid rock. Generating lava on a regional scale. This fragmented, multi-engine interior explains why Io's volcanoes erupt independently. With no global rhythm. Each region pulses to its own geological beat. Even more striking, Juno's readings of gravitational oscillations reveal that Io's crust is far thinner than previously thought. Just 20 to 40 kilometers thick. This fragile shell floats precariously above constantly churning magma pockets. Making it vulnerable to rapid collapses, sudden eruptions. And the formation of new peaks in astonishingly short timescales. It's this thin crust that grants Io its dramatic, ever-changing face. The discovery of a decentralized, compartmentalized magma structure marks a turning point in planetary science. It shows that powerful geological activity doesn't require a planet-wide molten layer. Instead, a web of localized magma chambers driven by relentless gravitational compression can sustain dynamic behavior over astronomical timescales. This realization offers an exciting lens for interpreting other celestial bodies outside our solar system. Where interior processes may differ entirely from anything seen on Earth. Every new insight into Io's internal structure is a humbling reminder. The universe plays by rules we are only beginning to understand. Io is not just a moon, it is a living laboratory, a natural engine of energy transformation. Tectonic evolution and extreme dynamics. It compels us to look deeper, to wonder what other strange, seething worlds await discovery in the dark reaches of the cosmos. Exploring Io does more than deepen our understanding of geological activity. It constantly pushes the boundaries of modern science. Every structural feature, every volcanic cycle, every burst of plasma interaction becomes a crucial link in a chain of phenomena that transforms this moon into an extraordinary case where classical rules are put to the ultimate test under the most extreme conditions imaginable. Recent images from the Juno spacecraft and major ground-based telescopes confirm that Io's landscape is in constant flux. New lava lakes emerge, solitary mountains suddenly rise from plains, and its surface is blanketed with chemical snow. That melts away just as mysteriously. Even Io's thin atmosphere challenges definition. Revealing how blurred the lines are between physics, chemistry, and planetary dynamics. Fusion that creates a world where states of matter are in perpetual transformation. Io has rewritten the standard model for satellite behavior. It raises critical questions about the limits of geological evolution. The power of tidal forces, and the profound connection between planetary environments and universal physical and chemical processes. The lessons drawn from Io extend far beyond our solar system. Forming a foundation for new methods of exploration. Especially in searching for highly dynamic exoplanetary systems, and evaluating how life and matter might adapt and evolve in the harshest of realms. Io reminds us of a powerful truth. The diversity of worlds in the universe far exceeds our ordinary imagination. Perhaps, countless mysteries still wait in the shadows of places we've yet to explore. With every orbit around Jupiter, Io sends Earth another message. One that speaks of nature's limitless creativity. And one that sparks a horizon of curiosity and discovery for the generations of science yet to come. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.